Right, let's continue on with part 2 of parsing the command line. I had some caffeine, I'm a little more awake now. Hopefully this will be a little more energetic and this part will go more quickly. All right, what we just did in the previous part was we actually read some arguments from the command line. Right back here, we extracted rows and columns. That was from problem 1. Right, we simply did that. We assumed that argv1 and argv2 existed, and we used the ASCII to int function to just convert those strings to integers. All right, so let's see what problem number 2 asks us now. We're going to take that same idea. We have the same behavior, right? We're going to produce similar output, right? Same output as number 1 above. But instead of processing the command line arguments in main, we're going to write a separate function named parse command line. It's going to then read those functions, so we're going to have to pass the command line arguments to it. It's going to convert argv1, that string, to an integer value for rows, and argv2 to an integer value for columns, right? And it's going to return 2 values. In order to return 2 things from a function, right, a function can only return 1 through its return data type. We're going to have to use pointers to do that. So the prototype is going to be written as shown here. All right, I've given you an included example, but I'd rather just go ahead and work through how we develop that example from scratch, because you'll have to end up doing that in homework, of course, based on working examples. Let's go ahead now and go back to our problem. We want to then create this function. So let me copy this now. Back here, and let's just start. Now we call this practice 1. Let's go ahead and say this is file, save as. Let's just call it practice 2. And let's add this to the project. Remove practice 1. All right. So we're taking what worked. We're going to now add a function to it. All right, so here's our then function prototype. All right. Now down here we assumed that these existed. We simply then extracted these 2 arguments. So if we want to implement similar behavior in our function, so here's our function definition, right, where we actually then define its behavior by doing this, right? So here's what we were doing in main. We were simply doing this, right? If we put this in up here, right, here we're still assuming argv1 and argv2 exist. We want to go ahead and store that in rows. Now here in main we defined rows and columns as variables. Here they're already defined as pointers. So they point back to some of their area memory. Right, now this is going to return an int. So the data type this returns is an int, right? But the data type, if I just use rows, that name, this data type is a pointer to an int. So I now need to dereference rows. When I dereference rows, use the indirection operator, then that gives me the int data type since that points to an int. Same way with columns. Right? I can do this. Right. Now back down here, if I still want a variable called rows, I can have rows here. I can have columns. And now in order to call my function, right, I'm going to call it by name, parse command line. The first thing it expects is the argument count. Here my argument count is variable argc. Right. Then I also need to pass it argv as well. I need to pass it the address of rows here, because here my rows is simply an integer, right? So the address of rows is a pointer, and so I'm passing that here to this parameter rows. I'm going to pass the address of columns. When I come back down here, let's see if we have our rows and columns. All right. Let's just go ahead and compile this. Right, it's warning me that I'm not using the argument count for anything. I'll ignore that for right now. Let's just go ahead here and let's run the cursor. All right, so here we are in main. Right, our argument count is 3. There's a pointer to the area of memory where argument vector of strings is stored. Rows and columns have junk in their memory. Right, these here, I could say arg. Let's delete that, delete. Here in main, if I want to say what's argv at index 1, right, we can see that's the number 4, argv, or the character string 4. Argv at index 2 has our character string 5. That comes from the fact that in the previous example, I had set the program arguments to 4, then space 5, 4 rows, 5 columns. That's where that comes from. So if we now step into this function, right, so now up here, right, rows and columns are pointers, right? They're pointing back. This pointer here named rows points back to this area of memory. We gave it the address of rows. This pointer columns points back to this area of memory that belongs to main, columns. So now if we call the ASCII to end function, right, that's going to then return the number 4, store that rows, store this in columns. Right, now the next line when I go back to main, right, rows and columns have been populated, and that will simply display. Right? So not that many changes in order to make it a function. Now, what's not good about this is that we're assuming that we're always getting at least 3 arguments from the command line. Normally what we do is we write something like this. We say so in this problem, they need to pass us rows and columns, meaning we need our argument count needs to be at least 3, right? That, remember, the first argument is always the name of the executable. So if argc is less than 3, right, what we want to do is we want to just print out some sort of message, puts, right, we say something like usage, then, all right, now we usually give the name of the executable. A lot of times you'll see me write a message like this, a.out. If I'm working in Linux or Unix, a lot of times when I compile, this will be the name of my default executable, a.out. I might say something like program.exe, meaning the name of the executable, or I might just then say number of rows. Sometimes you'll see it like this, number of rows. Number of columns. What I'm trying to suggest is the fact that this should be an integer number of rows, integer number of columns. Right? It's hard to convey all of that in a message. If a user's using my program, they should know something more about it. Chances are we've given them instructions saying this program has the special purpose of creating an array that's so many rows and columns wide. So they have to have some knowledge of what they're passing to main. And then I would just go ahead and end the program. I might put a message there saying program terminating, something like that. And now, if we call parse command line, then we know we have at least 3 arguments. Let's just go ahead and build that. Let's set the program arguments, right? So now if there are no arguments here, right, and we run, right, we see then this message pops up to let the user know they didn't enter all the information they should have. And similarly, right, if I just set 1 argument there, right, if I just have the number 4 all by itself, right, now our argument count will only be 2. And again, here again, if we run this, right, once again, our argument count is not large enough. So now, if we go ahead and put in another one, 5, and then run, right, we'll get what we did before. Rows 4, columns 5. So it returned the two values. Now in here, there's one other thing. We're still assuming here that we know when we call this function argv1 and argv2 exists. We know that that still exists. Sorry about these little pop-up messages here. Not quite. That's coming from my Windows news stream. Sorry about that. Ignore it. Anyway, when we do this, we're assuming that these strings have numeric values in them, right? And we're not checking for that. What we might want to do is think about what AI returns. What happens if we mess up these strings? So here, I'm going to go back. And when I set these arguments, what happens then if I have an A there and then a 5? So now when I run this, right, we get 0 for rows, right? Simply because A to I returned a 0 for that argument of A. So one thing you might want to do, if in here we were actually, after we got this, if we wanted to actually create this 2D array, right? If we needed to then say, hey, let's declare the 2D array. Assume it really doesn't matter if it's an array of doubles, chars, ints, whatever it is. If it's an array of doubles, right, we might say, hey, rows, columns, right? But 0 rows doesn't make any sense. We might want to then say if rows greater than 0 and actually if rows is less than or equal to 0 or columns is less than or equal to 0, right? We're going to say error reading command line arguments, right? And let's go ahead and print out what's stored. Rows, columns, program terminating, terminating -2. Right. So if our program, right, was going to declare the 2D array based on that, then we're safer by checking this, right, making sure that we have something to create here. And so now let's build this and let's run it. And now we get that error message simply because rows happen to be 0, right? We had, remember in setting the program arguments, I had that letter A there. And now let's go back to the case where this is a 4 and this is a 5 and everything works, right? And if we run that, right, we get our rows and columns. So there's another safeguard, right? We want to make sure that we got some sort of valid information here. ASCII to int was kind enough to return a 0 when it couldn't convert it. So we know we get an integer value, but 0 doesn't make sense in terms of rows and columns, so we added that extra safeguard here, right? You've now written a function that can return two things, right? Basically, these pointers to rows and columns were used to affect areas of memory here. So when we say it returned two pieces of information, what it did was it changed memory, right? It changed memory, it pointed to rows and columns, changed this memory back here, and it effectively returned two things. We didn't do it through the return data type, we did it through parameters. We use these pointers as outputs. All right, so that was then the gist of problem 2, right? We'll move on then in problem 3 to a string comparison. That will be the next video.